Okay, so let's come back to the slides. Please make sure you read the course syllabus, policies, and lecture schedule carefully after class. And you can ask me if you have any questions or unclear parts. For this course, we have low discussion session. Therefore, please make sure you make a good use of the office hours of both TAs and instructors. So I will be the main instructor for this course in this quarter. And my research is focused on AI, and we have a special focus on machine learning, deep learning, data mining, and big data. I will host the office hours virtually via Zoom on Tuesday, just in the morning after class. And we have 2 TA, and I will post the TA's office hours later, and I will let you know. And then you tell me why you want to take this course, and why you plan to reject this course in this quarter. We all know deep learning nowadays is very important, but for the undergraduate students, probably it is not very clear for you what is deep learning and why it is so important, and what the deep learning will be like in the future. In this page, I will show you with some videos prepared for you. It talks about deep learning in the past and deep learning applications in the real-world services, as well as the futures of deep learning. And we can share them together. Let's look at the first one.
Go is the world's oldest continuously played board game. It is one of the simplest and also most abstract.
Beating a professional player at Go is a long-standing challenge of artificial intelligence.
Everything we've ever tried in AI just falls over when you try the game of Go.
The number of possible configurations of the board is more than the number of atoms in the universe.
AlphaGo found a way to learn how to play Go.
So far, AlphaGo has beaten every challenge we've given it, but we won't know its true strength until we play somebody who is at the top of the world, like Lee Sedol.
A match like no other is about to get underway in South Korea.
They said all is to Go what Roger Federer is to tennis.
Just the very thought of a machine playing a human is inherently intriguing.
The place is a madhouse.
Welcome to the DeepMind Challenge.
The whole world is watching.
Can Lee Sedol find AlphaGo's weakness? Whoa. Is there, in fact, a weakness?
The game kind of turned on its axis.
Look at his face.
That is not a confident face.
It's developing into a very, very dangerous fight.
Ooh, hold the phone. Lee has left the room.
In the end, it is about pride.
I think there's something went wrong.
Yeah, it's made a mistake.
He's got to pronounce America.
These ideas that are driving AlphaGo are going to drive our future.
This is it, folks.
Okay, so the first video actually is about AlphaGo in 2017. It is a very big news in that year, if you still remember. So generally, via the machine learning and AI and deep learning techniques, we can build a model to play the Go game with a top human Go player, like Lee Sedol, right? It is very complicated because Go have so many different ways to play, right? On the Go chessboard, there will be so many different positions to play the Go, this stone. So the search space for the location to play the Go stone actually is so large. It is beyond the processing capacity of all computers. However, the machine learning and deep learning we can search for this kinds of space very effectively and efficiently. So this is about what deep learning can do in the past. And then we have another video prepared for you for the deep learning application in the real world, which is in our daily life. Okay, watch them together.
Ever wondered how Google translates an entire web page to a different language in a matter of seconds? Or your phone gallery groups images based on their location? All of this is a product of deep learning. But what exactly is deep learning? Deep learning is a subset of machine learning, which in turn is a subset of artificial intelligence. Artificial intelligence is a technique that enables a machine to mimic human behavior. Machine learning is a technique to achieve AI through algorithms trained with data. And finally, deep learning is a type of machine learning inspired by the structure of the human brain. In terms of deep learning, this structure is called an artificial neural network. Let's understand deep learning better and how it's different from machine learning. Say we create a machine that could differentiate between tomatoes and cherries. If done using machine learning, we'd have to tell the machine the features based on which the two can be differentiated. These features could be the size and the type of stem on them. With deep learning, on the other hand, the features are picked out by the neural network without human intervention. Of course, that kind of independence comes at the cost of having a much higher volume of data to train our machine. Now, let's dive into the working of neural networks. Here, we have 3 students. Each of them write down the digit 9 on a piece of paper. Notably, they don't all write it identically. The human brain can easily recognize the digits. But what if a computer had to recognize them? That's where deep learning comes in. Here's a neural network trained to identify handwritten digits. Each number is present as an image of 28 × 28 pixels. Now, that amounts to a total of 784 pixels. Neurons, the core entity of a neural network, is where the information processing takes place. Each of the 784 pixels is fed to a neuron in the first layer of our neural network. This forms the input layer. On the other end, we have the output layer, with each neuron representing a digit with the hidden layers existing between them. The information is transferred from one layer to another over connecting channels. Each of these has a value attached to it, and hence is called a weighted channel. All neurons have a unique number associated with it called bias. This bias is added to the weighted sum of inputs reaching the neuron, which is then applied to a function known as the activation function. The result of the activation function determines if the neuron gets activated. Every activated neuron passes on information to the following layers. This continues up till the second last layer. The one neuron activated in the output layer corresponds to the input digit. The weights and bias are continuously adjusted to produce a well-trained network. So, where is deep learning applied? In customer support. When most people converse with customer support agents, the conversation seems so real, they don't even realize that it's actually a bot on the other side. In medical care, neural networks detect cancer cells and analyze MRI images to give detailed results. Self-driving cars. What seemed like science fiction is now a reality. Apple, Tesla, and Nissan are only a few of the companies working on self-driving cars. So, deep learning has a vast scope, but it too faces some limitations. The first, as we discussed earlier, is data. While deep learning is the most efficient way to deal with unstructured data, a neural network requires a massive volume of data to train. Let's assume we always have access to the necessary amount of data. Processing this is not within the capability of every machine. And that brings us to our second limitation: computational power. Training a neural network requires graphical processing units, which have thousands of cores as compared to CPUs. And GPUs are, of course, more expensive. And finally, we come down to training time. Deep neural networks take hours or even months to train. The time increases with the amount of data and number of layers in the network. So, here's a short quiz for you. Arrange the following statements in order to describe the working of a neural network. A. The bias is added. B. The weighted sum of the inputs is calculated. C. Specific neuron is activated. D. The result is fed to an activation function. Leave your answers in the comment section below. 3 of you stand a chance to win Amazon vouchers, so hurry! Some of the popular deep learning frameworks include TensorFlow, PyTorch, Keras, Deep Learning 4J, Caffe, and Microsoft Cognitive Toolkit. Considering the future predictions for deep learning and AI, we seem to have only scratched the surface. In fact, Horus Technology is working on a device for the blind that uses deep learning with computer vision to describe the world to the users. Replicating the human mind at the entirety may be not just an episode of science fiction for too long. The future is indeed full of surprises, and that is deep learning for you in short. If you enjoyed this video, do like and share it. Also, subscribe to our channel if you haven't yet, as we have a lot more exciting videos coming up. Fun learning till then.
Okay, so the second video provides a very brief introduction about what is deep learning and what deep learning can do, right? So in this course, we provide a more detailed introduction about deep learning as well as specific techniques and methods to use them in the real-world application problems. And the last video we want to share with you is about the future of the whole world with the assistance of deep learning and AI technologies.
Google, Facebook, Apple, Microsoft are all moving ahead at a great speed in improving this artificial intelligence software. So it's very exciting. Software is going to solve that, where it'll look at all the new information and present to you, knowing about your interests, what would be most valuable. So making us more efficient.
We're focusing on what we've talked about on autonomous systems. And we sort of see it as the mother of all AI projects. So autonomy is something that's incredibly exciting for us. We'll see where it takes us.
Wouldn't it be wonderful if someday we got to the point where there were robots every place, they were running farms, they were running Apple, they were running Berkshire Hathaway, and all you had to do was one person could punch a button at the start of every morning, and all the goods and services that we're getting now would be turned out by robots.
It is seeping into our lives in all sorts of ways that we just don't notice. We're just getting better and better at it, and we're seeing that happen in every aspect of our lives, from medicine to transportation to how electricity is distributed. And it promises to create a vastly more productive and efficient economy. And if properly harnessed, can generate enormous prosperity for people, opportunity for people, can cure diseases that we haven't seen before, can make us safer because it eliminates inherent human error in a lot of work.
Artificial intelligence is going to be extremely helpful, and the risk that it gets super smart, that's way out in the future and probably worth talking about. But now what we're seeing is that for the first time, computers can see as well as humans. That's pretty incredible.
NHTSA did a study on Tesla's Autopilot version 1, which is relatively primitive, and found that it was a 45% reduction in highway accidents. And that's despite Autopilot 1 being just version 1. Version 2, I think, will be at least 2 or 3 times better. That's the current version that's running right now. So the rate of improvement is really dramatic. We have to figure out some way to ensure that the advent of digital superintelligence is one which is symbiotic with humanity.
AI is probably the most important thing humanity has ever worked on. Now, I think of it as something more profound than electricity or fire. And anytime you work with technology, you need to learn to harness the benefits and while minimizing the downsides. Stepping back, when you think about a lot of problems in the world, today it's because we typically have a constraint on resources. AI, for the first time, I think over time, offers a different construct. Things which are constrained and look like a zero-sum game today may not be so in the future. Take education, for example. It's really difficult to educate people in a cost-effective way. AI may fundamentally change that equation. It may make it possible for us to have clean, cheap, renewable energy for the future. So I think a lot of things will play out in more positive ways than people think.
I think probably by end of next year, self-driving will encompass essentially all modes of driving and be at least 100 to 200% safer than a person by the end of next year. We're talking maybe 18 months from now.
The idea that there's going to be a general AI overlord that subjugates us or kills us all, I think is not something to worry about. I think that is overhyped. First of all, we don't know, we're nowhere close to knowing how to build a general AI, something that could set its own objectives. But second of all, I think it's unlikely that such a thing's first instincts would be to exterminate us. So I'm optimistic about that one, and certainly don't think we need to worry about it today.
So you can see for all the big names on the market right now, and they are all investing lots of money, lots of people, as well as lots of resources on deep learning for the future. So with this kind of investment, we can see the huge development and progress of this AI and deep learning technologies in recent years. So you can see, no matter what you plan to do for the future, if it is deal with computer science, it is deal with data, then deep learning will be a very powerful tool for you to use in your product, in your research, and in your future career. If you want to be like an IT guru at Goldman Sachs or Boeing, or you want to be a system developer at Google, Amazon, a data scientist at Facebook, Uber, a researcher at Microsoft Research or IBM Research, or be a professor exploring these kinds of fast-growing area in computer science, deep learning is a necessary tool and knowledge you need to know and handle, actually. We have some examples of deep learning applications in the real world. The first one is AlphaGo, right? We showed before. The why is AI and deep learning technology. We can build a machine to play the Go game with human beings. And besides AlphaGo is gaming, right? And we can apply the deep learning in other areas which is more closely correlated with our daily life, like in Amazon. Generally, via Amazon, by browsing some products, the system will recommend you with some potential purchases of other products as well. And this kind of recommendation is also heavily relying on the machine learning and deep learning technologies. And we have to build some models to learn the preference of users and to match the user with some products. And later on, we will show you how to use the graph neural nets to build a model to do the recommendations for the websites like Amazon. Besides this, when you're doing the searching in Google, actually they are also relying on machine learning and deep learning technologies. For example, if we are searching some keywords, the Google can actually pop up some options of some potential keywords you will be searching for, actually. In most of cases, all the words I want to search, they have been provided already, as shown in this page. And to achieve this kind of function, they have to utilize all the data, the search by the user before, and they can do the matching of the typing by the user right now to match with some other keywords searched by other users and provide them as a recommendation for the user to search, right? Another area which is very popular right now is about self-driving cars like Tesla or other car makers like Toyota, Honda, and BMW, right? They are all investing money on self-driving cars nowadays. If you have ever driving the Tesla car, generally on highway, you can use its autopilot, right, to drive the car by itself. It can generally follow the lane automatically, right? So to achieve this kind of function, we have to utilize deep learning models like neural network models to detect objects on the way and also do the controlling of the vehicles. Okay, so these are the examples of deep learning applications in the real world nowadays.